Yo, what's up, Sci Fam? It's your boy Nickel. Today, we're going to learn about how we can age the layers of Earth's crust, and that's known as relative age dating. We'll look at 3 laws that allow us to do this: the law of superposition, the law of original horizontality, and the law of cross cutting relationships. So let's dig right in. We're looking at the process of relative age dating, which this allows us to determine how old rock layers are. Well, at least how old they are compared to one another. Not their actual age, just which one is older and which one is younger. So if we see this purple here, let's label this as layer A. You can go ahead and draw this in your science notebook, and the brown one will be layer B. Now, A had to be in place before layer B could form on top of it. So therefore, layer A is actually an older layer. So A would be older and B would be a younger layer because B had to settle on top of layer A. Now, even though we know A is older and B is a younger layer, we actually don't know the actual ages. So let's add here, but even though we know A is older and B is younger, that's great, but the actual factual age, the actual age is still unknown. So we don't know if it's 2 million years old or 50,000 years old. No idea yet. We're just understanding that A is older because it's there before, and then B comes in, so that's younger. All right, so as we dig deeper, we're going to look at how we have 3 different laws that will help us understand the complex layers that we find underneath our Earth's surface. The first is the law of superposition, and super means on top of, so therefore on top of a position, the law of superposition means that when you have a new rock layer, those new rock layers are going to form on top of the pre-existing or the previous rock layers. So if we label these again with A being on the bottom and then B and then C, well, before B could be on top of A had to be there first. So therefore, we would say that A is the oldest layer. It was there first, then B, and then C. So therefore, here at the top, this is the younger layer, or the youngest layer. So it goes from oldest to youngest because new rock layers, as they form, had to form on top of the layer that's underneath of it. Let's look at law number 2. The second law is law of original, and this is a big word here, horizontality. Horizontality. Okay, let's break this down. Essentially what this means is that when you have rock layers, they originally are going to form in a horizontal type manner. So rock layers form horizontally. And if you think about like what the horizon is, a horizon line is like something that when you look out at the sky, where the ground meets the sky, you can see the horizon. And the horizon is something that goes from left to right. So therefore, when rock layers originally form, they originally form horizontally to the ground. And this is because of gravity. So as things fall down to the ground, they all fall on top of a layer, and things don't fall and stack up on top of each other. They instead form in a horizontal manner. So if you remember the sand activity that you did earlier, whenever you form a layer, it's going to form horizontally. You can't pile it up like a big tower and have things form around it. It all has to form in a horizontal fashion. Now, something that's important to know though here is that layers that are not horizontal, so layers that do not appear to be horizontal, that are not horizontal, they must have been changed by some type of event. And you might be familiar with some of these events. Some of these events could be something like an earthquake, or maybe even erosion, or the fact that our Earth's crust is moving over the magma that's below it, the asthenosphere. We could also have tectonic plate motion, which could cause those layers to not be horizontal. So let's take a look at these examples then. So if we label these examples on this one on the left here, and go ahead and draw this in your science notebook, we have A at the bottom, and then B is this purple layer. Let's have C be the yellow, then D, and then E. You see, what had to have happened here is that A had to form first, and then B had to form. C then is a result of B being eroded by a river. So you can imagine if there was water flowing through this rock layer, it would have dug out this kind of half circle shape. Then as sediment formed in the bottom of that river, that would be C, more formed on top of that, which would be layer D, and then finally after that, then E formed on top of all of those layers. So to put this in order, it would have been A first, followed by B, and then we would have had a river causing erosion, and then C, and then D, and then E. Now let's take a look at this example over on the right. This one, the layers are not horizontal, so something must have happened here. So if we label these, let's have A being at the bottom, then B, C, D, and then E. Now since all of them are angled at the exact same way, we could imagine that there's some really thick or dense piece of Earth's crust here that is either being pushed up against the layers, and when it pushes up against the layers, it causes the layers to be flexed and pushed upward. So therefore it causes this angular type of motion in the layers. But originally, these layers would have been laid down in a horizontal fashion. So I can use my tool here to show that originally these layers would have actually been something like that. But then when that tectonic plate motion happened, it forced them upward and caused them to be in the angle that we see them now. So let's take a look at a couple GIFs here to take a look at what would happen. So here on this one on the left, you can see exactly what I just showed. There's a force of motion coming from right to left, which causes those different layers to be forced upward, but they first start horizontally. Over here, you can see a more complex situation happening where we have forces coming from both sides. The layers are horizontal, but then as all of this crunching and squishing happens, you can see that the layers get all warped and moved and shifted and tilted. So you can see how different types of events can cause there to be different shapes underneath the Earth's surface, but we can still use the law of superposition to understand how they all stack on top of each other, knowing that we can have erosion or earthquakes or tectonic plates that can change that motion or the appearance of those layers. Now, let's take a look at what would happen if we have something coming up through the bottom, like a blob of magma or a volcano forming. So let's look at the law of cross-cutting relationships. And again, it sounds complex, but let's break it down and it'll make sense why we call it cross-cutting relationships. So when magma or volcanic intrusions, because a volcano is basically just magma coming up through the asthenosphere, through the Earth's crust, the lithosphere, to form a volcano. So it comes from the bottom up to the surface of the Earth. So when magma or volcanic intrusions cross through layers, so cross, that's where cross-cutting relationships comes from. When magma or volcanic intrusions cross through layers, they must be more recent than the layers they cross through. So there we have cross-cutting relationships. So we could say here that when we look at these different layers, let me get a different color here. Let's get some red, because we can imagine that there's the Earth's magma down below the layers. We can imagine that if there is a blob that kind of comes up, we can call this an intrusion. And in order for this intrusion to be aged, then, if you have something that comes up through the layers, it could even be more blobby than this. When it comes up through the layers, you can see that green and purple pink here had to be there before this magma plume could actually end up coming through it. So if we look at and we label these different layers, then let's find a color here that I can use to label the layers. Let's go with a blue color. So if we have A, B, C, D, and E, and then let's say that this magma is letter F, we know that A had to form first because it's on the bottom, and then B. Now we know that those had to be there before F could have formed. So F had to happen after B. Now we don't know if it happened after or before C because it doesn't cross through that layer. So all we can say is that F had to happen after B because it crosses through that layer. Now it could have crossed through that layer and then C could have formed, and then D and then E, or we could have had A, B, C, D, and E form, and then F could have come in and formed. So let's take a look at this other picture. We could also have something where perhaps there's a volcano. So let's imagine that we have that magma coming back up through the Earth's crust. So it's a tunnel here, and it starts to form some type of volcano. Well, we know that if this volcano were to form here in this manner, we know that all of the layers had to be there before the volcano formed because this magma stream goes through each of those layers. So therefore they had to be there beforehand. The layers don't form around that tube of magma, but instead the layers had to be there first. So if there are previous layers, if previous layers were not in place, for example, if they weren't there first, then the magma would have followed the law of horizontality, and the magma would have just spread out horizontally. Now we could imagine that if I were to draw another one to show what that means, is if, let's say the purple layer wasn't there, then magma would form in this way because the magma would have formed on top of the red layer here. And we can see it went through the green and the red layer because it's crossing through them. Since it doesn't cross into the purple, we know that the purple came after this magma because of the law of cross-cutting relationships. So we can use this information to age the Earth only in a relative way. We don't know what the actual ages are. We just know that one thing came before the other, and that is relative age dating. I'll catch you on the next video. SciFam, adios.